Well, hello, Caymans. Mr. Eicher here, coming at you with a lesson about polynomial equations and solving them. This is Chapter 4, Section 5, Part B. This video will be in two parts. We'll do one video on the first page, solving polynomial equations with 3 variables, and then the next page we'll do solving polynomial equations with 2 variables and with 4 variables, and then we'll show you an application of solving polynomial equations. So let's get started. For number 1, the first thing you should notice is, well, I guess there's a lot of things you could notice. It's already set equal to 0, so you could notice that. That's promising. We usually like things that are set equal to 0, so we could use the 0 product property. You can notice that there are 3 terms, so this is a trinomial. That's a good thing to notice. But the other thing that's the most unique that we haven't seen yet this year is these exponents. We have a x to the 4th and an x squared in the middle there. We're used to things that look like this: x squared minus 5x plus 6 equals 0. We've seen things like that before. But this year in Math 3 we have yet to see one with x to the 4th and an x squared. But thankfully, the way that you solve this one by factoring is the same exact way that you'll solve something like this. So actually, you probably already know how to solve it. Deep down inside, you know. So let's see. Let me erase some of this so focus a little better. So to factor this, what we would do is take the 1 and the 6. We multiply those, so that's a 6. And then we want factors of 6 that will add to negative 5. So if you need to write factors of 6, 1 times 6, 2 times 3, there's not too many of them. And it looks like this pair will be able to get us to negative 5 if we just make the 6 a negative. That would, that wouldn't actually work because it needs to multiply to positive 6 but add to negative 5, so they both would have to be negative, so that group isn't actually going to work. This group would work. They both would be negative. That would multiply to positive 6, and they would add to negative 5. So one like this you might remember. We could rewrite it as 4 terms, but anytime you have a 1 for a leading coefficient, you can jump immediately, using these factors here, you can jump immediately to the factorization. So I'm going to jump immediately to the factorization like this. And instead of having an x times an x, so don't write this, I'm going to write it in red, don't write this. Instead of having an x times an x, we're not going to have that because it needs to multiply. These two terms need to multiply to give us x to the 4th. So instead of that, we're going to write x squared times x squared, and that multiplies to give x to the 4th. If you're ever not sure what you should use there, you can always peek at this middle term. That x squared there is going to help you identify what that should be, x squared and x squared. And then, like I was saying before, you can jump right from this negative 2, negative 3. We can plug those right in, negative 2, negative 3. And that's the factorization. So this has now been factored. So that's the first step on all of these on this side of the page. We're going to factor first, and then we're going to use the 0 product property. We're going to set both of those equal to 0. And normally at this point, we would just add 2, or on the other side, add 3, and then we'd be done. But notice we have a squared there, so we have to go one more step. So we have to square root both sides. And when we square root, we get 2 solutions, a positive and a negative. So we would have x equals plus minus square root 2, and x equals plus minus square root 3. So notice we get 4 solutions. Because we had an x to the 4th here, we know that we should end with 4 solutions. The degree, just to review that term, this is a degree 4 polynomial, and a degree 4 polynomial should have 4 solutions, or 4 roots. And in this case, they turn out to be 4 irrational. They're square root of 2 is an irrational number, square root of 3 is an irrational number, so we have 4 solutions and they're all irrational numbers. One other thing just to point out to connect it visually, if we were to sketch a graph of a degree 4, this graph would have x-intercepts at plus and minus square root 2, so like square root 2, square root 3, negative square root 2, negative square root 3, and it would have x-intercepts here, that's what those solutions are telling us, and it's an even function, so it would probably look something like this if we were to sketch the graph. So it's pretty cool, these solutions tell us the x-intercepts, and then we can tell how many directions the graph has. It has 4 directions, and it's an even function. It's a positive leading coefficient and all those things. So that was number 1. Let's look at number 2. Number 2 might take a little bit longer just because we have a leading coefficient here of a 2. But we're going to multiply that 2 with this negative 3, so that's a negative 6. And we want factors of negative 6 that will get to negative 5. So let's see, that's 6 and 1, 2 and 3. And if I make the 6 a negative, that would give me, adding those, that would be the negative 5. So I can use those factors. Now I'm going to rewrite this to be 2x to the 4th. And then I'm going to split this middle term here. I'm going to split that to be a negative 6 and a 1. So we'd have negative 6x squared plus 1x squared, right? Because these two, if you actually add them, you would get back to negative 5x squared. And then minus 3 equals 0. So we have 4 terms here, and then we're going to take a greatest common factor out of the first 2 terms and out of the next 2 terms. So the greatest common factor between 2 and 6 is a 2, and the greatest common factor between an x to the 4th and an x squared is an x squared. And dividing that out, we'd have an x squared left, and we'd have a 3 left. And then for the next 2 terms here, the greatest common factor is just a 1. They don't have any other factor in common, so we have to put the 1 there, the plus 1. And factoring out a plus 1, we would have x squared minus 3 equals 0. And you know you've done this process correctly when you have identical binomials, which we do, so we can have the stuff on the outside, 2x squared plus 1, and the stuff on the inside, x squared minus 3, and that equals 0. So we would set both of these binomials equal to 0, and then we would solve for x. On the left, we would get 2x squared equals negative 1, x squared equals negative 1 over 2, x equals, square rooting both sides, equals plus minus square root of negative 1 over the square root of 2. That's pretty close to a good answer, but notice we have a square root of a negative 1, so we can pull out an I, and we also have to rationalize the denominator. To rationalize the denominator, you might remember you multiply the top and bottom by that square root 2. So it looks like our answer would be plus minus I root 2 all over 2. So that's one of our answers. Well, there's actually 2 answers there, the plus and the minus. And then on the right side over here, we would be a lot faster. So we would square root both sides, get plus minus in there. So we have plus minus square root 3. So notice on this one, we have, this is 2 real solutions, and we have 2 imaginary solutions. And our degree, going way back up here, our degree is it's a degree 4. Degree 4, so we ended up having 2 real solutions and 2 imaginary solutions. So what this tells us is if we were to sketch the graph, just do a real quick sketch, we're only going to touch the axis at 2 places. That's because it's the real number axis. And most likely the imaginary roots are going to be kind of bumps and curves in the graph, but it's not actually going to cross the axis there. So we might have a graph that looks like something like this. Oops, something like this. There we go. This is an even function because the 4. It crosses the axis at only 2 places, at root 3 and negative root 3. But it also has some, like an interesting little bump in the graph there. And you get those whenever you have imaginary solutions rather than real number solutions. But that was number 2. On to number 3, I'd encourage you to pause the video, see if you could answer number 3, and then you can check your work. I'm going to pause my video and you'll see the work momentarily. So pause your video and see what you can do. So on this one, we have a leading coefficient of a 1, so that's the kind of nice one that you can use these values right in there immediately, right there. And then I solved and I got plus minus 3, and I got a plus minus 2i because I had a square root of 4 and a square root of a negative number. So you can check your answers, and I will check mine. If you'd like to pause and try number 4 right now, that's going to be a try this. So if you do it now, you'll save yourself some time later when you're on Schoology doing the try this. Number 7 below is also going to be for you, but let's look at number 6 to end this video. So on number 6 first, it should be set equal to 0. So we're going to have 8x to the 4th plus 10x squared. Subtract 12 from both sides to make it equal to 0. And then the next thing I notice is 8, 10, and 12 are all even. Since they're all even, I can divide by 2. So that would be a good idea. If I divide everything by 2, it'll make the numbers a little bit easier to work with. So that would be 4x to the 4th plus 5x squared minus 6 equals 0. All right, and now we will factor. So factoring, we'll multiply 4 times 6, so that's negative 24. We got to get to 5. I think that would be 8 and negative 3 would add to positive 5. So we'd have 4x to the 4th, plus 8x squared minus 3x squared minus 6 equals 0. And then we group and factor by grouping. So we'd have, take out a 4x squared, we're left with 2x squared, plus, we're left with x squared plus 2. And then the next one we'll take out a negative 3, and that would be a x squared plus 2 equals 0. And we know we did this right because these are identical. So we'd have a 4x squared minus 3 times x squared plus 2 equals 0. I'd encourage you to see if you could pause the video and finish it from there. I'm going to pause my video, and the next time you see it, it will have the answer. So pause the video, see if you could take it from there. Ta-da! So I got 2 imaginary answers, plus minus I root 2, and then 2 irrational answers, plus minus root 3 over 2. So that was number 6. So on this page, you'll be doing number 4 and number 7 as a try this. So if you'd like, you can do number 7 right now. I will see you in the next video. Have a great day.